But yeah, so today I'm going to try to discuss trying to make your CI a bit more secure and a bit less spicy with some salsa, because, you know, salsa and security people like to say spicy a lot. So, of course, first of all, thank you to the sponsors, and that is a little bit self-congratulatory since I do work for one of the sponsors, but, you know, thank you to all the other sponsors. Right, so, since you're probably wondering, well, who the heck I am and why you should listen to me, which I wouldn't recommend, but I call myself a security-interested developer these days. I used to do other things. And we're currently working 2 degrees as an application developer. I got a PhD in computer science from the University of Auckland back in the day. A thing to note, and I want to emphasize, is that I'm still getting my own head around all this salsa business. It's, I'll get to it in a second, but it's not completely straightforward. And so I'm by no means an expert. I'm just a guy who spent a while reading the website and, you know, looking into it. So hopefully you get something out of it, but I do not claim to be the word expert by any means. And unfortunately, for time reasons, I'm going to assume today that you already know about supply chain security, software supply chain security issues and why they're a problem. Because it turns out I just don't have enough time to explain that and cover everything else. Oh, there are actually, I'll say at the end of the slides, a couple of things about some examples taken from the Salsa website, which weren't supposed to be included, but it's fine, they're there, you can look at them at the end of the slides. The slides are already up on the website. Right, so Salsa. That's pretty much how, you know, trying to write these slides felt like, basically. It gets pretty tangled and wacky pretty quickly. So if you haven't figured out, it's already, what is it, supply chain levels for software artifacts. I'm always getting that wrong. Pronounced like salsa. They have their own official website, salsa.dev, and they describe it that way. Basically, a framework to try and make sure that you're actually doing things securely. And so the aim is pretty much, it wants to make achieving software supply chain attacks much more difficult, if not impossible. I mean, probably never impossible, but, you know, much more difficult. It originally came out of Google. I think they started in 2013, and it's now a project of the Open Source Security Foundation, which is sort of, in a way, like OWASP, but not. They're another good organization you should look at. And so they released their first version 1.0 of Salsa in April last year, but it's definitely very much still a work in progress. In fact, they originally had much greater ambitions, and they scaled a lot of it back to get something out, pretty much. They're still trying to develop it and get it more advanced. Right, so the thing I want to note is that Salsa is part of a much greater interconnected system. There's things called Salsa, Fresca, Sigstore, Tecton, and Toto Attestation, and there's more of them as well. Seriously, well, the first time I was reading through the website, they're like, oh yeah, and we use this and see that, and it all turns into a very tangled web very, very quickly. And the other thing is all these projects seem to be at least kind of sort of independent from each other, so it's not like they're sort of one coherent streamed thing, entirely at least. They do work pretty well together, it seems, but it, you know, if you sort of just go and look at the website and start going, well, hang on, there's a lot to this, there is. And because of all that, I'm just going to focus on a bit of Salsa at a very high level today, because there just isn't enough time to go nearly into as much depth as, you know, would actually be good. Right, so another thing to note is that Salsa, this image is taken straight from their website. So they've got all sorts of different security threats you can have, and they explicitly say they only focus on some of them, the ones with the green ticks next to them. Building from modified sources and using compromised dependencies, compromising a build process and uploading a modified package. So pretty much the bits where you are either consuming something that someone else has produced or producing something for someone else to consume, like as a developer. And this talk's not even going to try to focus on all of them. It's going to kind of, sort of, maybe cover building from a modified source, using a compromised dependency, and uploading a modified package. Kind of, sort of. Right. So, various elements of Salsa. I don't really want to belabor this because you can read the definitions, but they have specific definitions for different things, which I'm going to keep using through the talk. And basically, if you don't quite know what I'm talking about, it might get a bit confusing. So like they say, for instance, a build's pretty much really what you'd expect. It's taking your inputs, running some sort of build process and producing an output. That's not too hard. They basically say everything, you have input artifacts and output artifacts, which could be different things. So an artifact is basically just an output of some sort of binary, a mutable blob of data, they say. So usually, for the most part, they're trying to talk about libraries that you use there, but it can be actually anything that's like you can point to as a discrete blob of data, essentially. And a dependency is pretty much any artifact that you depend on in your build process, shockingly enough. Source, they say, is any artifact that you can, like someone involved in the development process has either created or hand reviewed and then hasn't been modified at all since. So, I mean, obviously like your source code or, you know, if you've got, say, a fixed version of a library that you're using that someone's actually pulled down and gone through and you're not like pulling down another version from elsewhere again. And then a package is basically anything that you publish or has been published for other people to use. And so sometimes when they say package, that's the one particularly where it gets a bit, like you might be thinking that's not a package, but for their purposes it is. Right, so originally SLSA had, I think they had 3 different tracks they wanted to go for, and they ended up saying, actually, let's just pick one, this build track for now, and they're still working on putting the others up. And so this build track has, was it 2 main foci. So basically, producing packages for other people to consume where they can have some degree of assurance that it's, you know, actually from you and might be safe, and consuming said packages and trying to use the available verification stuff. And so currently they have these 4 levels of security, which I'll go through in a moment. But basically, you pretty much go from there's not really any attempt to be secure up to it's all kind of sort of super duper secure. I think there's was originally a level 4, level 4, which they're still trying to get back to in terms of in the standard, but it's not there yet. An important thing to note is you can't achieve a higher one without achieving a lower one. So you can't sort of pick and mix things. You actually have to have done everything at the lower level before you can get to the higher level. And another thing to note is that currently some of the levels are actually achievable with certain build platforms, which I will go into a little bit more later. Right, so the big part of all this stuff right now, at least for the build track and everything, is provenance. And when you get down to it, it's basically, I think it's actually just a JSON file, I can't remember now. It's pretty much just a text file describing, you know, the build process, what you used as your inputs, when you did it, where you did it, all that sort of carry on, including external parameters and internal and external parameters. So it's required for levels 1 and above, which again I'll come back to in a second. But if you don't have, you know, a reasonable, like if you don't have something saying this is how we built it, then you don't meet SLSA basically. Another important point is that at the high levels it's actually cryptographically signed, and that's an important part of providing consumers with a guarantee that it actually came from you. Is, you know, it's the old, we signed it with our private key, you can check with your public key, and if it doesn't match, then we know, well, it probably wasn't actually us, it's probably someone sneaking something in, which, again, I'll mention again later on. So producers basically, you know, produce it, and it's there available for them, for people, consumers to check, and then consumers take it, look at it, and, you know, use it in whichever way they please. Right, so another thing you might be thinking at this point is that SLSA provenance sounds an awful lot like software bills of materials, which I'm thinking most of you know what SBOMs are. I don't really have time to explain it, but the point is that they're very closely related, but they're not the same thing. So the SLSA website itself kind of describes it as being like, food production, industrial food production. So an SBOM is basically a list of ingredients, you know, what actual ingredients went into this thing. Whereas I say SLSA is a bit more like the standards and procedures they followed to ensure food safety. So, you know, how they make sure that the factory is cleaned up and you don't have people breaking in and pouring poison into your food and that sort of stuff. Is pretty much what they're trying to get at. And so, of course, my point is you use both. To be honest, producing both SLSA provenance itself can be pretty easy, and producing SBOMs for a lot of languages these days is pretty easy. Making it useful is a different story, but producing them is pretty easy, so really start producing both. Right, so coming to the main topic of the talk today, hopefully. SLSA in your actual CI. Now, a thing to note is that because this is all still kind of new and basically still coming out of Google, different languages and ecosystems in that have very different levels of support. There are, so there's some languages which have a lot of support, and I'll talk about that briefly in a second. Other sort of fairly generic tools out there which can be applied to basically any artifact. But I said before that only some build systems actually can get you to level 3 because they're the only ones that are deemed magically secure enough. I don't know. Basically, they seem to have decided who counts to level 3. And currently, it's only Google Cloud, shockingly enough, and GitHub Actions for whatever reason. I think basically they're the only ones that have actually gone through and they've certified, yes, we have enough internal controls to make sure our internal people can't screw with the system or that sort of stuff. I'm moderately certain many others, for instance, GitLab, I'm pretty sure that actually meet all the requirements and just presumably haven't actually been certified yet. And we're just going to focus on GitHub Actions because it's all I have time for, and it's also the one I have most experience with, to be honest. So there's really two things you can do right now, pretty much, is produce provenance for others to consume or verify provenance that others have produced. Right. So producing provenance, basically, it's if you're producing any sort of package for other people to use, it's the part you should be doing. You should also be verifying the provenance from other people whose packages you depend on to produce yours, but if you're producing something, you should really do this. So it lists all sorts of details about what was, how it was built, what was used, all that sort of stuff. Platforms, processes, inputs, all that sort of carry on. By itself, it won't actually do much to help you on a technical level by itself, because you're kind of producing something to help other people and give them confidence in your system. But if you've done everything to the point where you can actually be producing provenance to like level 2 or level 3, then people can have pretty good confidence that you actually have a not terrible CI system. That, you might actually have some basic controls in place and do things reasonably sensibly. So it should be sort of on a reputational basis. The fact you're producing it, makes you look better, and I don't know, it could just end up being the distinguishing thing between you and some other competitor who doesn't do it. And I'm sort of hoping that in time, as with SBOM, there's slowly becoming something where people are like, if you can't at least show us one, then we're not going to buy your stuff. I'm hoping it will get to that sort of level of self-provenance as well, where, just being able to produce it is a minimum standard. We're not there yet. I think people haven't even heard of it, but, we'll see. And so currently that's basically the main focus of pretty much the entirety of SLSA because they've only got the one track to foci and carry on. Right, so level 0 SLSA is just a complete lack of any assurance. It's basically the idea of a developer doing a local build on their own machine. There's no assurance. There's not really intended to be an assurance. It's like, I'm just doing my thing. Why do you expect there to be security yet? And so level 1 doesn't actually require any automation, I don't believe, as I understand it, but that basically requires that your processes are consistent, that you're actually, it's not just some developer that goes to the command line and types in build, publish, release, or whatever. There's a little bit more to it than that. And also it requires that there's some provenance, and they don't really state any details. From what I can tell, it could just be someone going to a markdown file and saying, this is the stuff that we use, this is how we done it. And that would be considered good enough for level 1. So level 1 is really pretty simplistic. It's pretty much just, do we actually do things in a normal fashion, and have we written down how we do it? It's pretty much all it seems to be. And there's no requirement to sign stuff cryptographically. But as I said before, you have to meet level 1 to be able to go any further. And I'm assuming most people in this room who produce any sort of software will at least meet level 1 pretty easily right now, I hope. So level 2 is where it actually gets vaguely interesting. So level 2 is that your builds are always performed on dedicated infrastructure. So, like a build server or a cloud build system, say. Pretty much anything like that. It's no longer just some developer doing it on his machine and then uploading it somewhere. It's a developer doing it on a dedicated development machine and uploading it somewhere. And of course, importantly, this is the level where you have to start digitally signing your provenance, which is just the usual, you have your private and public key and you sign it with the private ones, people can verify it with the public key. And the point here is that it becomes a lot harder for someone external to, somehow get in and fake your package and be like, oh yeah, this is totally the next version of it, really. If, say like your NPM account gets compromised or something, but they can get into there to upload a fake package, but they can't actually get into your build system. So you're still pretty vulnerable to insider threats because people might, like if you've got someone who has got access to the account and the build system and they potentially screw up stuff. So level 3 is basically that, but more rigorous, I'd say. Level 3 is that, your build system's actually hardened against anyone screwing with it. If I remember rightly, all builds have to be completely isolated so that there's no chance of, it can't be they do one build with a funny parameter and then the next build reuses something from that previous one that's wrong and just managed to sneak something in. I mean, I'm guessing most people, that's probably not going to be an issue anyway, but it should be that, you can strictly say, yes, no, we have no reuse of stuff and people can't do that, sort of carry on. And of course, the key material for signing the provenance should never be exposed. I mean, I'd hope you'd try your best to make sure it's never exposed anyway, but it has to be pretty strictly done. I think that's the sort of part where only certain platforms get rated for level 3 right now, is that sort of thing. It requires a bit of making sure you've actually got stuff in place, basically. And so the point of level 3 is that it makes it very difficult for anyone to muck for the build process. It doesn't stop someone writing in malicious bits into your program. Just emphasize, that's not what Salsa's trying to do. If you've got your developers just write, delete the customer's files into it and hit publish for the usual process, Salsa doesn't cover that at all. It doesn't try to, at least, not yet. So, just a very quick thing about doing GitHub Actions. So GitHub recently themselves put out a action themselves for producing provenance. And so basically what they do is they give you a file, they produce a file that says, you built this with GitHub Actions, here's the stuff, and then it's cryptographically signed, and it actually gets uploaded to somewhere, and that goes back to the other things I mentioned earlier where it's all kind of tangled up, but I don't really want to go into that today for time. The Salsa project itself also has some builders and generators. So the builders, I think there's only ones for NPM, Go, and Java off the top of my head. Maven specifically, I think it is. And so they actually run the whole build process and do attestation and everything as part of it, and pretty much seem to say we do all the stuff you need. They also have themselves some generic artifact signing stuff. So you can, if you just go like Salsa GitHub Actions, I think it's about the second result. There were some others out there as well, but I think those were produced back before there was really anything else available, and I don't think I'd recommend trying to use them if you're just starting now. But just, you could find others that I'm pretty sure are legitimate. So builders actually seemingly do the whole process of building and running, building everything in that. The generators basically just take something that you've already produced and produce attestation for it. The generators that the Salsa project themselves produce predate the GitHub Actions ones. I'm not sure they'd actually try it now if they, do it now if they were starting again, because I think probably the GitHub ones, as far as I can tell, is fine. One thing that I could not find anything about was it's unclear to me whether these generators, both GitHub's ones and the Salsa projects, actually meet level 3 requirements or just level 2. I didn't spend forever looking into it, but I could not figure that out. The builders, they explicitly say meet level 3 requirements. I couldn't quite figure out for sure the generators if they do or not. I'd say if you're using one of those and people are complaining at this point, they're a bit silly, but yeah, just be aware. I can't guarantee that they actually meet level 3. Right, so consuming provenance, the other side of the equation, basically it's just checking that yes, this thing actually came from where it claims to have come from. So you get some details on where and how a package was built. Importantly, the provenance is digitally signed, and so what you want to do, of course, is that you pull down that provenance and check the signature against what you've got, what you are expecting. And again, there's ways they do all that, which I'm not going to say. And so basically, that means that if the attestation matches up properly with the artifact that you pulled down, the package you pulled down, you can be reasonably sure it isn't that someone else has managed to sneak in and put an illegitimate package in its place. It doesn't guarantee it's secure because they might have just written viruses into it, say, but it means it's probably not someone else has swapped out the real one for a fake one. And yeah, so that whole mucking about with legitimate builds is just not currently in scope of SLSA. And so to consume provenance, they don't actually have a GitHub action directly. They have a CLI command for the GitHub command line interface, which, shockingly enough, you can use from inside GitHub Actions, which I've done to make sure that this actually works. I'm not entirely clear if their one works for the other provenance generators. It should do, is my understanding, because they should all follow the same standard, and it should all be perfectly fine. But I couldn't find anyone actually saying anything about interoperability with each one. And I didn't quite get around to trying it myself in time, to be honest. And so, you know, you can use, SLSA themselves also have a verification system, and so you can use that too in the actions. I'd say if you're using the SLSA stuff, probably stick with SLSA. If you're using GitHub, stick with GitHub. I don't know it matters, but probably better. Again, there are others out there, but these probably definitely should be your first choice because they're the ones that actually seem to have been rigorously worked on. And of course, the verification part of it, which is really the entire point when you're a consumer, really, when you get down to it, is saying, you know, did this actually come from the people who are claiming to be putting these things out? And did it come from their actual build process? You just pretty much run the verification thing to check the signature and all that. And, you know, it can be as simple as just a yes or no, does this match up? And obviously, if it doesn't match up, stop the process, don't continue building your system, because something has gone wrong. And maybe it wasn't malicious, but something has gone wrong, because it should always come back as a pass. And if it doesn't, you know, things are mapped up. Right. So the thing I want to mention, basically, is that really, okay. First thing I want to mention, which now I realize probably should have been in a different spot. Anyway, SLSA doesn't address all possible issues with dependencies. So left pad, you know, a package just suddenly disappearing off the internet, it does nothing to protect against that. It's not supposed to. Polyfill IO, I don't know if you remember this one. That was the one where it was like a JavaScript dependency, but they'd serve up different stuff depending on your browser user agent, and someone got in there and started serving up malicious stuff just this year. And because that was coming from the legitimate producer, basically, you can't actually stop it with SLSA because it would pass verification. And protest where again, the actual, you know, package author decides to change the behavior themselves, SLSA can't stop that because it's coming from the person who actually claims to produce it. And again, they're not really trying to stop that, to be honest. But I mean, a lot of these things, not necessarily all, but a lot of them can be mitigated or prevented to some degree of other measures. And basically, when you get down to it, what SLSA is really pretty much saying is do a lot of what I'd call the fundamentals well of your CI process. I don't want to call them the basics because they're not all completely basic, and you know people seem to struggle with them. But I call them the fundamentals. And really, what it's saying, pretty much, you can have SLSA and have these verification levels and all that, but it's basically saying, you know, do your build system pretty well. And so, what are these fundamentals that I'm talking about? So, first of all, automate everything that you can. I know one of the speakers yesterday said he hated people saying automate everything because I think he thought people like doing it overly bad or something. So obviously not everything can be automated. If it could, we wouldn't have jobs as developers. But where you can automate it, if just because in that way you can be pretty sure things are consistent, and then also you can shove stuff off to a dedicated build infrastructure and, you know, not have to worry about all that sort of carry on. And use said dedicated separate build infrastructure where possible, both because it should help keep things isolated and, you know, you don't have weird things from your machine suddenly sneak into the production version. And it also means that, you know, developers can keep developing instead of sitting there waiting for things to compile and run tests. If you can, delegate responsibilities to trusted platforms where they've actually, you know, like how with the cloud where you say, okay, well, we sort of assume their data center, they've actually literally got armed guards and, you know, barbed wire fences and all that sort of thing. So it's going to be pretty hard for just some random person to break in and screw around with the place. Not guaranteed, not possible, but pretty hard. Same sort of idea, they might have actually, you know, spent some time and effort trying to make sure that all that stuff is at least secure from someone getting in and tampering with it, whereas if it's just the server down the back, maybe someone just goes up to it and plugs a USB stick in and who knows. And of course, importantly, you know, closely control privileges and permissions in that and monitor for things not suddenly going all wacky. I think most people should be pretty good for that, but, you know, you should only give people the power that they need. So like, give developers the ability to say, please run CI for me, not, go in and screw with the runners themselves and that sort of stuff. And importantly, of course, where you can cryptographically sign your output to your artifacts, these GitHub actions actually make it pretty easy to do that side of things. It's pretty much just you stick a step into your build pipeline, which is produce verification, produce attestation, sorry, and it produces something and gets uploaded that you can go look at it. And that's all very easy. And then importantly, you go and actually verify these signatures, or if you've got a fixed version of a package that you're consuming, there's quite possibly a reasonable chance that you can take like a SHA-256 hash of it or something like that, and then just check, does the one I just pulled down match that hash? And I've done that in a previous job myself, where we actually done that because something was significant enough that we decided, yes, we actually want to make sure we're getting the exact same file again and again. And the point being, you don't need salsa to do that. You can get basically pretty much all the same security benefits for yourself by doing all this yourself. It may be easier, actually, for these new actions to be able to do it using that, and then you get the reputational benefit of, hey, look, I'm using salsa. But basically, try to follow steps like these, and you should have a pretty secure CI to begin with. Right, so that's all I really want to say today. There's a bunch of links. I could include a whole bunch more, of course, but some links. These slides are actually already up on the source website under my, if you look on the schedule under my talk description or whatever, the slides are already there available for download, so very easy to find. And yeah, that's pretty much it. I think we might have time for one question or two.
Do we have any questions?
Thank you for that talk. I'm curious about the attestation piece.
Yes.
Presumably there are standards then for distributing those public keys as part of SLSA?
Yes, so I don't fully understand all the details because, like I said, it gets all very spirals out. And so there's something called SigStore, which, as I understand, is where they actually put the information. And so you can run your own private instance, or there's a public good instance, I think, stood up by Google. And so basically it puts all the relevant pieces into this SigStore system, which I think they say is blockchain based. I'm not sure that's actually true, but so pretty much that all gets uploaded to somewhere that can be accessed and consumed from, and in theory that's well secured and trustworthy. And then the attestation in theory is supposed to be produced according to this in toto attestation standard, which again is another separate project that I don't think those two started off having anything to do with each other, and then realized that, hang on, we're both like solving parts of the same problem, so let's work together. So the short version is, yes, there are some standards. I just glossed over them for the sake of time.
Do we have more questions? I guess we can take just one more. Thank you so much, James.
Thank you.
For the lovely talk.
Thank you.